Hi everyone, welcome to the Internship Studios session on AWS monitoring. So, as a cloud or DevOps engineer, if you are working in the enterprise, or you can say like there are some modern technical positions that are coming up, such as the site reliability engineer or the observability engineer. So, it's very important to learn AWS monitoring or any monitoring tool in general because you are running some enterprise applications here and it becomes very important that you keep track of all the infrastructure that is powering up the application. For example, if it is hosted on Kubernetes, then you have to monitor the Kubernetes clusters, or if it is hosted on ECS, like the Elastic Container Service, you have to be sure of the resource utilization there as well. Or if you are hosting it on ECS, then for example EC2, then it also becomes important to monitor those EC2 instances as well. So we'll understand from the basics what this monitoring does is, and we'll also have a hands-on session here. So before going to the advanced topics, so let's understand in generic terms what is monitoring. So in IT, which is the IT industry, information technology, monitoring refers to the process of observing and tracking the performance, health, and activity of various IT systems, infrastructure components, applications, and services. So the primary goal of monitoring is to ensure the optimal functioning of these IT elements, identify potential issues or bottlenecks, and promptly address any problems that may arise. So this is a kind of a generic definition. So we'll understand this more simpler using an analogy here. So we'll take the example of a garden. So you may be familiar with your house gardens or any your organization or college or any like outside park where there are many trees. So we can consider the realm of IT as a vast and intricate garden here. So with different plants representing the diverse components of an organization's digital landscape. So in this analogy, IT monitoring takes on the role of a diligent gardener. So a very careful gardener here, tending to the various elements to ensure a thriving and resilient ecosystem. So we'll take the garden as a whole. So the first thing that comes up is the diverse IT components. So we can picture the IT infrastructure as a garden filled with a variety of plants, each representing servers, databases, applications, and networks. So just as a garden requires careful attention to sunlight, soil, and water, IT components demand monitoring for performance, security, and overall health of the systems. So here we have the gardener who takes care of the garden, right? So it can be related to the IT monitoring as careful oversight. So in our analogy here, the gardener symbolizes IT professionals equipped with monitoring tools. So like a skilled gardener, they observe the digital landscape, analyzing the growth patterns, which are the performance metrics of each plant. So plant means the IT component. So it may be a server, a storage, or any load balancer example. So here the gardener identifies signs of distress, any potential pests. So pests means any cyber threats in our case, and nutrient deficiencies. So nutrient deficiencies can lead us to operational issues through vigilant oversight. So next comes watering. So watering and sunlight are very essential, right, for plants. So similarly, the resource management is also helpful in IT. So in a garden, we have this proper watering and sunlight are essential for plant growth. So similarly, IT monitoring ensures the optimal allocation of resources such as bandwidth, processing power means RAM or CPU, and storage. So by fine tuning these resources based on the real time data, what IT professionals will do is they guarantee that each component receives the necessary nutrients for efficient operation. Next aspect also that we consider is pruning and weeding. So if there are some any weeds that are grown beside the plants, then it will hinder the growth, right? So this also will we can correlate in the IT systems for any issues. So proactive issue resolution is very important here. So just as a gardener plucks away dead branches and weeds to maintain a healthy garden, IT monitoring allows professionals to proactively address issues. So by identifying anomalies and potential threats early on, IT systems can deal away vulnerabilities and weed out any potential problems before they negatively impact the overall health of the garden. So fertilization is also important in case of a garden. So in aspects of IT, we have the continuous improvement and updates. So as per se in gardening, fertilization is crucial for ongoing health and growth of the plants. So similarly, IT monitoring supports continuous improvement by identifying areas for enhancement, whether it's updating the software of the systems, implementing new technologies, or optimizing configurations. IT professionals ensure that the digital garden remains very fertile and capable of adapting to the evolving needs. So next also like in terms of gardening we may do some high-tech gardeners what they do is they do weather forecasting for the plants. So similar to that we have the predictive analysis in IT. So just as a gardener checks the weather forecast to anticipate any upcoming conditions, IT monitoring provides predictive analysis. So by studying historical data and trends, IT professionals can foresee potential challenges, plan for scalability, and make informed decisions to weather the changing conditions of the IT environment. So next also we have the something called as greenhouse collaboration or cross team cooperation in IT. So maintaining a flourishing garden often involves collaboration between different specialists. So there may be some soil health technicians who will assess the condition of the soil, right? So the gardener may not know all the technicalities of a plant as well. So there may be some botanist who comes and visit them in a while. So similarly in IT we have cross team cooperation, so which is akin to a greenhouse, where experts from various domains, for example, in an enterprise application environment, we have teams that are called as QA, testing, and developers. Or nowadays we have something called as DevOps engineers team, who are like a middleman from QA and developers. So in an enterprise environment, these all the domains work together to address very complex challenges. So here IT monitoring facilitates this collaboration by providing a shared platform for different teams to analyze and respond to the unique needs of each component. So at last, like after taking care of the garden, the end of cycle is harvesting it. So whatever plants or any crop that you have sown, so after a certain amount of time, it's about reaping the benefits. It means harvesting. So next will be like in terms of IT environments, it will be extracting value from our day-to-day operations. So in the end, just as a gardener reaps the rewards of a well-maintained garden, so what IT professionals will do, they will extract value from their monitoring efforts. So the data harvested through IT monitoring becomes a very valuable resource, offering insights into system performance, user behavior, and areas for future growth and innovation. So at end of the day, it's saying millions and millions of dollars or rupees for enterprise applications and the companies. So in a way, they are also keeping in mind the resource constraints as well. So IT monitoring here emerges as the indispensable tool for cultivating a resilient, flourishing, and adaptive digital ecosystem. So ensuring that the garden of technology yields a very bountiful harvest for the organization. So this was about a small analogy that we had. So coming to the next thing, we have the key aspects of monitoring. So the first key aspect of IT monitoring include performance monitoring. So tracking the performance metrics of servers, networks, databases, and applications to ensure they operate within acceptable parameters. So this involves measuring factors like response times, resource utilization, and throughput. So we can take performance monitoring as the, for example, for an easy analogy, we can take the dashboard of a high-end support sports car. For example, any Audi or Porsche, whichever you can take as an example. So in a car, you can see it provides real-time speeds and any like for example, modern cars have real-time mileage, like how much the mileage the car is giving per liter, and what's the average speed that you're driving. So it kind of gives insights how well the engine is running. So in the IT world, this involves keeping a close eye on the health and efficiency of systems, networks, and applications. So think of it as a vigilant driver watching the speed, fuel levels, and engine temperature. So performance monitoring tools, what they do is they help IT professionals track response times, resource utilization, or overall system health. Response times means the latency of the application. So if a customer is trying to access a web application, so in what time the web page is giving the response, and resource utilization. If the pages are uh, loading very slow in terms of applications, for example, in a mobile application, if you scroll through any categories, for example, Flipkart, any category you are browsing through and just navigating. So if there is any slowness, it depends on resource utilization. So some backend server is facing some resource constraint issues. So it's very, in modern times, performance is very critical in uh, because actually they are matter of a profit and loss for the enterprises. So mostly like these key components will involve monitoring server response times, tracking the resource usage, for example CPU or memory, and analyzing network latency or ensuring the application performance. So why it matter is actually it helps identify and address the bottlenecks also. So like which aspect of performance is being slowed. So next is also optimizing resource allocation. So we'll also understand what type of resource and how much resources should be allocated to each system. And next is overall enhancement of the user experience. So like for example, if you open an application, so it should be very smooth from start to end, right? The time you hit the application and enter into it, and by the time you come out of it, doing whatever you want inside it, it should be a very smooth process without any hiccups. So performance matters a lot. Next is the availability monitoring, second one. So it ensuring that IT systems and services are available and accessible to users when needed. So this includes monitoring for downtime, outages, and disruptions. So we'll take another simple analogy here, which is a lighthouse in the stormy night. So for example, in seas and all, you have seen lighthouses, right? Which guide the far ships to cruise right to the ports or any direction. So availability monitoring here is like having a reliable lighthouse guiding the ship safely through stormy nights. So it focuses on ensuring that the IT services and systems are available and accessible when needed. So imagine the lighthouse as a beacon of assurance, so signaling that all is well. So availability monitoring tools help IT professionals track uptime, downtime, and response to ensure that the digital services are consistently available for users. So there may be some key components there as well. For example, monitoring server and service uptime, then tracking response to user requests, also ensuring some data accessibility, verifying the availability of critical applications. So it matters a lot actually because it helps us in minimizing the application downtime and service interruptions. For example, in a year we can say a certain application is down. For example, we can take the example of Flipkart. So Flipkart is down for around an hour. So in advance we can say that, for example, in SLS we can mention that it would be down for 1 year. So in that way we know like when the application is going to be down. So also next is improving user satisfaction. So if the customer already knows that at a certain point of time that application is not gonna uh, provide the service, then it would become easy for him or her to navigate through and accordingly plan his purchases or any operations he does. So next is also the meeting of the service level agreements. So it also helps us in adhering to any predefined SLAs. SLAs means any guidelines or, for example, agreement kind of thing set up between any cloud hosted vendor or and the application company. So third component we have is the security monitoring. So it's like the fortifying the digital castle walls. So you have any fort walls, right? Big forts. So it's like fortifying those, but in this case, digitally. So security monitoring acts as the vigilant guards for very observable, patrolling the digital castle walls. So protecting against any potential enemies or intruders. So it involves continuous surveillance to detect and respond to security threats. So picture the guards watching for any suspicious activity and promptly responding to any potential breaches. So security monitoring tools, what they does is they assist IT professionals in identifying anomalies, mean, mm, some monitoring access logs and safeguarding the organization's digital assets. So key components also here like there will be some monitoring of network traffic for unusual patterns. So it may be analyzing some system logs for security events, then detecting and responding to unauthorized access, then conducting some vulnerability assessments. So it security monitoring also matters because it helps us prevent any data breaches and prevent any unauthorized access from the outside world. Next is it also helps us ensure compliance with security policies. Uh, Also, it helps us safeguard any sensitive information of the customer as well. So, to read out the definition, it says keeping an eye on security related events and activities to detect and respond to potential security threats or breaches. So, this involves monitoring logs, analyzing network traffic, and using intrusion detection systems. Next is the log monitoring. So log monitoring is nothing but analyzing and monitoring logs generated by various systems and applications to identify and troubleshoot issues, track user activities, and ensure compliance with security policies. So let's take some different analogy here. Let's say uh, like it's I think it's similar to a detective carefully examining a logbook to unveil the sequence of events. So a detective is detecting crime scene of how everything has happened. So in IT, similarly, what is there is logs are records of activities. So and log monitoring involves scrutinizing these records for insights. So you can picture a detective or from any CBI or any private detective piecing together clues from a crime scene. So log monitoring tools help IT professionals analyze logs from servers, applications and networks to identify any critical issues, troubleshoot problems, and investigate security incidents. So here also action items may include analyzing system and application logs, monitoring user activity logs. You can identify also error messages and warnings, and tracking changes in configurations. And also why this thing is important and why it matters is it helps us troubleshoot issues and identify the root cause. So in DevOps or cloud environments, we something called as RCA, which is the root cause analysis, which is very significant in resolving any production issues. Production issues means any application customer facing issues which is out there in a real world. Next is also it helps us investigate the security incidents in case any, and also it helps us maintain systems and applications integrity. So we also have this alerting and notification systems. So we can like this they say that setting up alerts and notifications to inform IT administrators or support teams about abnormal conditions, failures, or potential problems. So this enables rapid response and minimizes downtime. So if something goes haywire, there must be someone to there must be something to notify you, right? So you can say, like, for example, we have nowadays there is it is the digital era of smart homes. So you already see some corporate offices having some smoke alarms. So alerting and notification in IT is like having a smart smoke alarms in the building. So these alarms, what they do, they promptly notify homeowners of any potential dangers. So if anyone is smoking or if any fire is caught up, so it will notify accordingly. So in similarly in IT, this involves setting up the alerts to notify IT professionals. So alert may be any small email or any text message to the phone which it is configured. So it will notify accordingly when some conditions or thresholds are breached in the systems. So imagine receiving a notification when something requires immediate attention. So alerting and monitoring and notification allows these tools play a very crucial role in ensuring a rapid response to potential issues. So also it also helps us setting up alerts for performance thresholds, so we can notify the relevant teams for any security incidents. So if some developer team is having some issues, you can notify that to the developer team. If something is gone wrong in the QA team, also you can accordingly notify the right guy of that QA team. Also it helps us catch the system failures or any downtime, and also it helps us establish notification workflows in our modern day-to-day work. So this also fosters actually, and it helps us enable proactive issue resolution. It also reduces response time to incidents, and also it minimizes the impact of potential IT problems. So these were some key aspects initially. Next is the capacity planning. So what this is monitoring resource usage over time to forecast and plan for future capacity needs. This helps organizations avoid performance degradation due to resource exhaustion. Next, we have the incident response. Having processes in place to respond to and resolve issues identified through monitoring. So this includes escalation procedures, troubleshooting steps, and communication plans. So we can imagine like capacity planning, like you are going to build a big multi-million dollar construction project. So you can imagine an architect meticulously calculating the size of rooms, the number of floors, and the strength of foundations for that construction project. So similarly in IT, we have this capacity planning, with which involves forecast. Forecast means estimating in uh, way before actually that project or any work starts, and preparing for the future needs of the digital infrastructure to ensure it can handle the growing demands of users and applications. For example, now you can say today my application is having 1000 users, but if that goes well, you should have the ability to forecast the right numbers. So in 1 month, how much customer base you may be having, for example 1 lakh, or in 10 months you may reach 1 crore. So that forecasting is very important in IT, because it helps us in estimating the future resource requirements as well. So today I may have 1000 servers, in future I may require 10,000 servers. So accordingly I need to upgrade the CPUs and memory and storage of them as well. Also what this helps is it helps us keep track record of the historical usage patterns as well, like how the application has been used throughout its life cycle. Also it helps us in predicting growth trends and user demands. So it also helps us in allocating resources efficiently for optimal performance. So this also helps us in actually preventing some performance bottlenecks, optimizing resource utilization, and ensuring scalability to accommodate any future demand growth. Finally, we have the incident response. So incident response is also similar to alerting and notification, but here we are actually doing the main plan of action. It's like fire brigade responding to an emergency. Uh, Picture firefighters rushing to the scene, assessing the situation, and employing strategies to contain and resolve the fire which has happened in a city. So, similarly, in IT, incident response is just like fire extinguishers. So, it involves promptly addressing and mitigating the impact of security incidents, system failures, or any unexpected disruptions. So it helps us in detecting and identifying incidents. It also helps us assess the severity and scope of the incident. It also helps us in developing and executing response plans. And also it helps in recovering the systems and service to normal operations. And it also matters because it helps the minimizing of downtime and service interruptions so that any customer is not annoyed or is not frustrated due to this service. So next is the reduction of the impact of security breaches. And also it's learning, actually end of the day it's learning from the incidents to improve future response. So you can also, if you know how to respond to a particular event, then you'll be more equipped with that skill for future incidents as well. So these are about some components. Next is the benefits of monitoring. So why we need to monitor the systems? The first one is the improved system performance. So monitoring identifies bottlenecks and helps optimize the resource usage. As we discussed earlier, so the servers that are serving the application, we can fine tune them actually. We can, I think if some, like for example, if an application or the server, the RAM is filling up, so you can automatically find that and go ahead and rescale the RAM capacity to higher levels so that it will optimize the serving of the application as well. Next is enhanced security. So monitoring detects and alerts on potential security breaches or vulnerabilities. So it helps us firefight then and there itself and address any potential security breaches or any vulnerabilities. For example, if someone is trying to accidentally hack into the systems, then using or any IAM user, for example, you can, in case of AWS IAM user, identity and access management system. So if someone like has leaked the credentials, then if someone is going to step into the system, we can enable MFA to the cyber security team, and that person will take care of the incident actually. So by this way there is enhanced security as well. So next is obviously the cost optimization. So monitoring helps identify unused or underutilized resources, leading to significant cost savings. So nowadays with the advent of cloud computing, what happened is the risks are become but the upfront costs are very less. What we say capex is very less nowadays due to cloud, but opex, which is the operational expenditure, is very high unless you have very uh, what you can say, very nice architecture or any application that withstands all the pillars of AWS and is also optimized on cost. For example, nowadays what we call FinOps. So if you have any in-house FinOps experts, then cost related and you can have any return of investment on the application. But if you don't design the application for cost optimization, then things can go haywire and actually you can incur losses in the long run. So it always helps. Monitoring what does is it helps us right size the infrastructure according to the application needs. So end of the day, it's matter of profit for organization. So the benefit of monitoring is also cost optimization. So these are some, you can see these are some monitoring tools that are available in the market today. So infrastructure means the backend systems that are powering the applications. So we have Zabbix, we have Xenos, we have Isinga, we have Nagios, we have Topbeat. Uh, but in modern times, the most demanding ones we have is Prometheus. So we have Prometheus, we have Datadog, and we have Fluent Bit. Many, like we have Jaeger, which is tracing. So these are the in demand. As you can see, lot of job descriptions nowadays they mostly demand this Prometheus and Grafana combination actually. These are actually deadly combination for uh, handling these DevOps activities day to day. So this is about the infrastructure monitoring. Next we have the analytics tools. We have tools from Elastic, we have from Solar, we have Greylog, we have Fluentd. So I've been confused with what this log analytics here is. So log analytics in IT, it refers to the process of analyzing and deriving insights from the log files generated by various components within the IT system. So log files are nothing like they are just records that capture events, activities, and messages generated by the software applications, operating systems, servers, network devices, and other IT infrastructure elements. So log analytics involves collecting and parsing and interpreting these log files to gain valuable information about the performance, security, and overall health of a IT environment. Next, we have the APM tools, which is application performance management. We have packet beat. So this is one tool that is awesome and very application centric. Next, we have the dashboarding. So we have dashboarding for Kibana, we have for Graph8, and we have for Grafana. So this dashboarding is a very modern concept as well. So it refers to creation and utilization of the visual dashboards that provide a very consolidated and real-time view of key performance indicators of the application. So it may be any metric or any data relevant to the performance and health of the organization's IT environment. So these are actually graphical representations. So you can have the visual in front of you. So it helps IT professionals or any layman managers who are not technically sound and don't understand the technicalities. They are like some decision makers. So what they can do is they can quickly assess the status, trends, and overall condition of various IT components and processes and take a decision by just referring that. So you can think of that like just a dashboard. Like you have the car's dashboard, right? We have this instrument panel displaying information about the car. Similarly, these dashboards use charts, graphs, tables, and other visual elements to represent the IT data into easily understandable format. So what it does is, for example, non-technical people, it will facilitate quick comprehension and decision making. So also we have option of real-time data. So similar to live news feed, dashboards provide real-time updates on the current state of IT systems. Like at this minute, how the infrastructure is behaving. So these dashboards they often pull data in real time or near real time actually, allowing users to monitor the latest information on system performance, user activities, security incidents, and any other relevant metrics that may say. Also, you can customize this. For example, you have widgets in your smartphone, right? So similarly, dashboards can be customizable to meet the specific needs and priorities of different users. So these IT or DevOps engineers they can choose which metrics to display, arrange them according to importance, and tailor the dashboard to suit their workflows. So KPIs we can see like we earlier I had taken the old as key performance indicators. Like we have the scoreboards in sports game, right? For example, football we have scoreboards. So opponent 0-2 like that. So here dashboards also showcase key metrics that indicate the overall health and performance of the IT environment. So dashboards prominently display KPIs relevant to IT operations, such as we have this response times of the server, we have the system uptime, we have error rates, we may have any security alerts and other metrics critical to the organization goals. Also, these dashboards are actually designed with user friendliness in mind, so ensuring that IT professionals and decision makers can easily navigate and interpret the information presented without getting lost in technical jargon. So yeah, this is about dashboarding. So coming to the AWS monitoring. So we'll see how AWS monitoring is in terms of, like, AWS, what all the native stuff it has. Uh, the first thing that comes is CloudWatch. Actually, AWS CloudWatch is a very comprehensive monitoring service provided by Amazon Web Services. It collects and tracks metrics, logs, and events from AWS resources and applications. So CloudWatch provides real-time insights and helps monitor performance, troubleshoots issues, and automate actions. Actually, AWS did a wonderful thing like back in 2010, almost around 10 years, or I think close to 13 years back. Exactly, as of 2023, as of 2024, sorry. Mm, it can, it was launched in 2010, so it was launched as a monitoring service for AWS resources. So it provided then very basic metrics and alarms. So at that stage, it primarily focused on metrics related to Amazon EC2 instances. So EC2 was fairly like there were fairly less services released back then. So it only monitored like CPU utilization, network traffic, and disk input after operations. So that time users could set up only alarms based on these metrics to receive notifications when certain thresholds were breached. So next, coming like 2011 to 2013, in the subsequent years, like from then, AWS expanded the CloudWatch to support the additional AWS services and provide a more extensive set of metrics. So that included support for metrics related to Amazon RDS as well. So they supported Amazon Elastic Load Balancers and more. So the service also introduced customizable dashboards. So it allowed users to create visual representations of their metrics for a consolidated view of their applications and infrastructure. So in 2014 to 2016, they came up with logs. So one of the significant enhancements that we can say to CloudWatch came in 2014 with the introduction of CloudWatch logs. So this allowed users to aggregate, monitor, and store logs generated by AWS resources, applications, and services. So log groups and log streams provided a structured way to organize and analyze the log data, so enhancing the overall observability of applications running on AWS. So next came the events and alarms enhancements. So 2016 to 2018, we had the advent of AWS CloudWatch events. So introduced in 2016, I think. So it allowed users to respond to changes in AWS resources in real time by triggering events based on predefined rules. So additionally, CloudWatch alarms received enhancements enabling users to create composite alarms and set more sophisticated conditions for triggering notifications. So I think after 2021 they came up something called as container insights. So as containerized applications gain popularity, right? Nowadays you can say Docker based applications, container D based applications, CRA.O based applications. So there are some container based products. So as these gained popularity after 2021, so AWS CloudWatch introduced container insights to monitor, troubleshoot, and optimize containerized workflows orchestrated by either Amazon ECS or Amazon EKS. So this allowed users to gain visibility into performance and health of the containerized applications. So actually CloudWatch continues to be a very key component of the AWS ecosystem. So it evolves to meet the changing needs of cloud users every day. So the service evolution reflects very broader industry trends towards more advanced monitoring, observability, and automation capabilities in the cloud. So this is about like how AWS CloudWatch works at the higher level. So we have the SNS email notification service, which is a messaging service from AWS. We have the auto scaling, which helps us with resizing, like for example, scale up or scale downing of the resources. So we have the AWS management console through which we can view the statistics. We have the Amazon CloudWatch alarm, which can be configured to set up for some specific topics. Next was the Amazon CloudWatch here we have the metrics. For example, we can have the CPU metric, percentage, we have the week count. So any like numerical metric we can attach. So this in the backend it will take information from any infrastructure that is hosted. For example, EC2 or an RDC instance or an S3 bucket, anything that may be powering it up. Actually, at a high level, it works in the backend by collecting, storing, and managing the monitoring data gathered by various AWS resources and services. So the backend infrastructure of CloudWatch is actually designed to handle many large-scale data ingestion, storage, and analysis to provide real-time monitoring and visibility into the performance and health of AWS resources. So there are some components like data ingestion, metric collection, data storage, log collection, alarms and notifications. We have the metrics explorer. So it's actually designed to be highly scalable. It means it will scale up and down based on the needs. So it handles the ingestion and processing of large volumes of metric and log data from a multitude of AWS resources. Actually, nowadays it also includes machine learning based anomaly detection to identify any unusual patterns in metric data. So, this helps users proactively identify issues and take corrective actions. So, this is about the workflow. Next, we have is the CloudWatch metrics. So, CloudWatch metrics are time ordered sets of data points representing the behavior of AWS resources. Next, the metrics can be collected from various AWS services such as EC2, RDS, S3, and Lambda. And also, these metrics enable monitoring of CPU utilization, network traffic, disk activity, and more. So, we can understand by seeing an analogy here. So, imagine you have a bunch of electronic devices in your home, like we have a refrigerator, you may be having an air conditioner or a cooler, and a smart TV. So, to keep them running smoothly, you are performing regular health checkups on each device. So, AWS CloudWatch metrics are like vital signs and checkup results for your electronic devices. So, think of CloudWatch namespaces as different rooms in your house where each type of device is located. So, firstly, we'll take the AWS EC2 namespace. It's like a living room where your virtual servers reside, which are the EC2 instances here. So again, the AWS slash S3 namespace we can take as kitchen where your storage buckets is located. So another thing we have dimensions. So dimensions are like unique identifiers for each device helping you distinguish between them during checkups. So for an EC2 instance, dimensions could be specific attributes like the instance ID indicating which virtual server is being checked. So metrics are like health indicators or measurements you check during a device health checkup. For example, you may take CPU utilization metric for EC2 instance is like checking the processor's health, ensuring it's not overworked. For example, if CPU utilization is measured at 80%, it indicates the processor is quite busy and you might need to address the potential issues. So you also have the concept, like what you can say, the concept of timestamp here. So checking CPA utilization at different timestamps help you understand if the processor is consistently busy or if there are spikes during specific hours. For example, if the server is busy from 12 to 9, there would be some graph like thing happening. So at around 6 or 7 p.m., there would be high sudden spike. You can see that the utilization is maximum at that point of time. So actually in essence we can say that these CloudWatch metrics act as health checkups for your AWS resources. So just like you regularly check and monitor health of electronic devices in your home, by understanding the vital signs and addressing any potential issues, you can keep your digital house or AWS environment for example running smoothly and efficiently. So this how like for example this is the old AWS console, but I have just taken it for reference from the internet. You can see uh, it is for an EBS volume attached to an EC2 instance. So you can see different characteristics. We have the read bandwidth, we have the write bandwidth, we have the read throughput, we have the write throughput. So you can see the different metrics here. So the graph is spiking somewhere in the middle at that point of time which has got the request. So we have the average queue length, we have the time spent idle, the average read size, average write size, we have the average read latency, the average write latency. So you can customize according. So in the hands-on session, we'll see how we can customize the dashboards as well. So this is a sample picture of the metrics. So next is the CloudWatch alarms. So CloudWatch alarms allow setting thresholds on metrics to trigger actions or notifications. So alarms can be configured to notify via email, SMS, or trigger an automated response. So they help identify and respond to operational issues before they impact system performance or availability. So you'll understand using some analogy of early warning system for digital storms. If you are coming any cyclone, for example, you have warning systems, right? So imagine you are the captain of a ship sailing through vast ocean of the digital world. So navigating your way through various challenges. So AWS CloudWatch alarms are like ship's advanced weather prediction system. So alerting you to potential storms before they become full-blown disasters. So first what you'll do from the port, you'll sail the ship, right? You'll start your ship and embark on the journey. So before you embark on your journey, what you do? You deploy several ships. Ships here are AWS resources into the ocean. So each ship has critical component like engines, navigation systems, crew members, and you want to ensure they are all functioning optimally. So CloudWatch metrics we have where like it's like monitoring the ship's vital signs. So previously we saw the electronic device health checks. So here it is kind of ship. So your ships have instruments which is like CloudWatch metrics. They constantly measure vital signs like engine temperature, fuel levels, and crew activity. So these metrics give real-time information about the health and performance of each ship as they sail through the digital seas. So now we want to stay ahead of potential storms. So CloudWatch alarms are like your advanced weather forecasting systems. So you set up alarms to watch any specific metrics such as engine temperature. So if the temperature starts rising beyond a safe threshold, an alarm is triggered. So we'll see the alarm scenario. So what we'll do first, we'll set the alarm. So we set up an alarm to monitor the engine temperature of each ship. The threshold is set to 80 degrees Celsius. So as a captain, we'll set it to 80 degrees Celsius. Next is normal sailing. So as long as the engine temperature stays below 80 degree, everything is normal. So your ship continues sailing smoothly. So third point what will get storm warning. So suddenly one ship's engine temperature start rising and it crosses the 80-degree threshold. So as soon as that 80-degree threshold is reached, the alarm is triggered. So the CloudWatch alarm is triggered, signaling an early warning of a potential issue with the ship's engine. So then what you'll do after the alarm is triggered, you will take immediate action. So just like captain taking immediate action to steer away from storm, you address the issue on the ship with the rising engine temperature. So perhaps you adjust the engine settings or schedule maintenance for that. So as in all, you can see that the benefits of CloudWatch alarms is it helps us in proactive monitoring. So it gives us early heads up about any potential issue before they impact the AWS resources. Next is also the timely response. So by receiving alerts promptly, you can take timely actions to investigate, troubleshoot, and resolve problems, minimizing downtime or any disruptions. Next is prevention of disasters. So, CloudWatch alarms help you prevent digital disasters by addressing issues at a very early stage, just like steering away from a storm before it intensifies. So, all in all, it helps us as a trusted weather forecasting system. So, here you can see this is just high level setup. We have the region. Under region we have a VPC. So under VPC we have these three availability zones. So one security group you have configured in one availability zone. and next we have the other security groups and other availability zones. But if there is some any change here, an alarm is triggered. So if anyone tries to uh, play around with the security group rules, so an alarm is triggered and CloudWatch alarm is sent to SNS, and then it will go to Lambda accordingly. So this is about the high level overview. Next we have is the CloudWatch logs. So CloudWatch logs enable centralized logging and analysis of logs from various services. It provides real-time visibility into application and system logs for troubleshooting and analysis. So logs can be stored, searched, and monitored for specific patterns or events. So imagine you are an explorer venturing into the vast wilderness of the cloud, so discovering new territories and facing various challenges. So AWS CloudWatch logs are just like a trusty journal, capturing every step of your journey, every encounter, and every important detail. So as you explore, your actions, observations, and noteworthy events are all logged in your journal. So similarly, CloudWatch logs capture the activities, messages, and events happening within the AWS environment. So it's a digital journal for everything that occurs. So we have some analogous elements called log groups, log streams, log events. So they are like, for example, log groups you can think as different sections in your journal. So each log group represents a specific category or area of your AWS adventure. So log streams, they are nothing but within each log group. Log streams are like individual pages in that section. So they document the chronological sequence of events related to a very specific aspect of your AWS environment. Next we have the log events. So events you can say they are like the entries on each page. So they record specific occurrences or messages, much like your journal entries capturing specific moments during your exploration. So there are some benefits as well. So it helps us troubleshoot when there are some events or any challenges. So it helps us monitor the performance also. It helps us provide security insights and also helps in auditing and compliance. So this kind of a CloudWatch logs that we can say in the AWS console. So this is a sample logs. So here are some different timestamps. So for each timestamp, for example, we have these different messages. So you can visualize them easily. So we have the fields as well. Accordingly, you can discover the fields. We have the at ingestion time. We have the log stream, message, request ID, timestamp, the account ID, duration. So you have all the details available. So next is the AWS Cloud Trail. So AWS Cloud Trail provides a detailed record of actions taken by AWS accounts. So it captures API calls and related events, providing visibility into user activity and resource changes. So CloudTrail logs can be analyzed to detect unauthorized access, troubleshoot operational issues, and ensure compliance. So we'll see in detail how this thing is. So again, it's kind of a logbook for the AWS account. So it records every action again and interaction, acting as a detailed history of who did what in your AWS environment. So think of it as a security camera that captures all moments, helping you track changes, troubleshoot issues, and ensure compliance. So CloudTrail ensures transparency, providing a very chronological record. Chronological means timely manner. So it timeline of events we can say, such as resource changes, access attempts, and configuration modifications, allowing you to investigate incidents, monitor account activity, and maintain a secure digital trail of your AWS operations. So this is about how the AWS CloudTrail works. We have the API call made to the CloudTrail, then the S3 bucket. So then we have accordingly the alerts, analysis, and the other tools. So this is the high level flow. So another important component we have is the AWS X-ray. So AWS X-ray is a service that helps analyze and debug distributed application. So it provides an end-to-end view of requests as they travel across various AWS services. X-ray helps identify performance bottlenecks, troubleshoot errors, and improve application response time. So you can say it's like a digital map for tracing and visualizing the journey of requests through your application. So it helps developers identify and troubleshoot performance issues by providing insights into the flow of data across microservices. So microservice is a modern approach actually. So you can say modern applications like each component is built in a different what you can say different language or framework. So for example, if you take Flipkart application, so instead of building the whole logic, like for example including the sign in page, the checkout page, everything and underneath the UI, so each component is split into different parts. So I think for example the sign in page can be written in Python, the checkout page can be written in Golang. So accordingly you are segregating for better modularity of the application. So it is called as microservices. So this X-ray you can also think it of as a diagnostic tool that allows you to pinpoint the bottlenecks, analyze latency, and optimize the overall performance of the application. So with X-ray, you can also track requests from start to finish. So you can understand dependencies between different AWS services and enhance the overall efficiency of the AWS powered applications by gaining valuable insights into the interactions and behaviors of your distributed systems. So this is the high level workflow of the X-ray. We have the X-ray SDK here, which has some application code which of Java, .NET or Node.js. Then we have the X-ray daemon in the backend. So you can associate it with the scripts and tools. So we have AWS SDK and AWS CLI through which you can interact with the X-ray API. And also you can interact with the X-ray console via the web browser as well. Web browser in the sense the management console. So this is how about X-ray. Next we have the AWS Trusted Advisor. So AWS Trusted Advisor provides real-time guidance to help optimize AWS resources. So it analyzes account activity and offers recommendations for cost optimization, security and performance. So Trusted Advisor helps identify potential cost savings, security vulnerabilities and best practices. So all in all, we can say it acts as a cloud optimization and best practices expert. So think of it as your virtual assistant. So analyzing your AWS environment to provide personalized recommendations for cost savings, security improvements, performance optimizations, and any fault tolerance enhancements. So it scans your AWS resources, checks for deviations from AWS best practices, and offers actionable insights to help you optimize your cloud infrastructure. So trusted advisor is like having a knowledgeable advisor at your fingertips, guiding you to make informed decisions, enhance efficiency, and ensure your AWS environment follows industry leading practices for cost effectiveness and performance. So this is a higher level overview from AWS documentation. So as an AWS customer, you want the most value from your investment. So trusted advisor can help this say. So here is the AWS Trusted Advisor. So Advisor scans your AWS infrastructure, compares it to AWS best practice in 5 categories, and provides recommended actions. So they already have a set kind of instructions you can say which you can take help of and make your environment accordingly. So you have these main pillars. 5 pillars are the cost optimization first, performance, security, fault tolerance, and service limits. So there are some recommended actions for all these types. So you have this kind of recommendation and action links. So they show something kind of investigation recommended so that you may further reduce the cost. So related to performance, they say no problem detected. It means your application is running fine. So in case of there is any security misconfigurations, they give a warning called action recommended so that you can take help of the trusted advisor and navigate and fine tune them. So next is fault tolerance. It will also it says no problem detected. So if there is everything is correctly configured, then it says no problem detected. Next we have the service limits. So service limits also we have this recommendation of no problem detected. So if there is any, it will notify you accordingly. So I think we are done with most of the components of monitoring and the theoretical part. So we'll directly jump into the hands-on session now. So what I'll do is I just quickly spin up two or three EC2 instances. So without wasting time, so I quickly launched three instances already. So we'll quickly create CloudWatch dashboards for these. So I have named EC2 1, EC2 and one RDC instance. So that just for naming convention. So all the instances have public IPs and these are free tier eligible AMI Amazon AMI Linux based instances. So we already discussed in a theoretical slides that CloudWatch is a awesome dashboard configurator for AWS for various resources in our AWS account. So I'll quickly go into the CloudWatch. It's handy, so I'll click it here. Otherwise, you can go ahead and search in the console for CloudWatch and get it accordingly. So we can say the navigation console, right? In the left, we can see the dashboards, the alarms, logs, metrics, X-ray traces, events. So they are the different types of controls that we have regarding to dashboards. So we don't have any, dashboard here. So we'll go ahead and create our first dashboard now. So I'll go ahead and create dashboard here. So we'll create the dashboard now. So the name it should be such that it is very easy to actually understand. So since we'll check the CPU, I'll just type EC2 CPU dashboard. I'll hit create dashboard. So once you hit that, we see this beautiful add widget option. So we have different metrics that we can accordingly add the dashboard to. Firstly, we have the line, we have the number, we have the stacked area, we have the pie, we have the explorer, we have the bar. So we'll first select the line and the data sources type will be CloudWatch. I'll hit next. So successfully our CloudWatch graph is empty now since we haven't I think we'll add a metric here. So now we'll add the metric. So since our case it's a EC2, I'll select the EC2 and we'll also add the per instance metrics. So just type the CPU utilization now. So or we'll just hit CPU. So just select some instance and go ahead and create the widget for CPU utilization. So you can see they will get a widget called no data available since there is no resource utilization for that particular EC2 instance. So just go to 1 hour. Also there isn't any data available since there isn't any sort of operations being done on that. So next we'll go to the dashboards again. I can go ahead and create a different type of dashboard here. I'll just save and continue before going ahead. So dashboard name, I'll say for new dashboard, my second dashboard. Go ahead and create a dashboard for that. So now I'll take something called as number here. I'll click it next. I'll select EC2 again. Again per instance metrics. Again I'll select the CPU utilization. I'll just select a random EC2 instance again and go ahead and create the widget. So you can also see, don't see any CPU utilization since there isn't any instance configured accordingly. So next we'll go to the dashboards. So we have two what you can say dashboards. So we also have the concept of automatic dashboards here. So we can get the EC2 respected uh, things here. So we have the monitoring disabled here by default, but you can see the CPU utilization average. So it's at 19.7% and the networking average is at 350 kilobytes. Respectively, the network packets in average and packets out average are at 178 and 355. So this is how we can go ahead and configure a dashboard. So this was all about the hands-on session. So we'll go ahead and go back to the slide deck. So we need to learn some best practices as well. So the first thing is we need to define very clear monitoring goals and establish key performance indicators aligned with business objectives. Next, we'll implement a centralized monitoring solution to consolidate data from multiple sources. Also, we need to regularly review and analyze monitoring data to identify trends, patterns, and anomalies. So, always it's better that you have an observability team with you so that they will always have for very keen eyes on what resources performing at what levels and the infrastructure is healthy at all times. Also, we can set up proactive alerts and notifications to quickly respond to critical issues. So we can continuously optimize monitoring configurations based on changing needs and resource usage. Next, we can regularly conduct performance and load testing to ensure monitoring systems can handle peak workloads. So recommendations we have. So we need to leverage automation. So wherever applicable, always use Terraform like ISA tools like Terraform so that you can quickly change the infrastructure available at your hands. Next, we can implement scalable monitoring solutions that can handle increasing resource demands. We can have Prometheus or Grafana integration so that it makes us achieve better monitoring solutions. Next, investing in training and expertise to ensure proper configuration and management of monitoring systems. So this field is changing very rapidly, so it's always better to be updated to the latest skill sets. So we have a couple of case studies. So Netflix, you may be all familiar with. It's a open source content platform tool. So they use AWS CloudWatch, Atlas, and custom built tools for monitoring to power their infrastructure. So you can see that it's very rarely that you see this Netflix going down in a year. So they have a very robust application architecture. They are very highly scalable and automated monitoring infrastructure to handle their vast streaming service. So Netflix monitoring practices involve very proactive alerting, anomaly detection, and continuous optimization. So yeah, they also practice somewhat I think most of you may not be familiar with. So you may search in the internet. It's called chaos engineering. So what they do is they intentionally destroy their application infrastructure, which is a production one, and they'll play around with how to bring that back fast online. So you can type chaos engineering and deep dive into that if you have some free time in your days. Next important one we have is the Spotify. So Spotify is a popular music streaming service, you may all know. So if you use some Android or iPhone, so you can just type Spotify. It's a music streaming service. So they also host their environment on AWS. So they utilize a combination of open source and custom monitoring tools for their music streaming platforms. So they focus on real-time metrics including user activity, resource utilization, and service performance. Also, these guys also are very robust in their architecture. They quickly identify and resolve issues to provide seamless user experience. So they use a combination of Lambda, CloudWatch event tools. So Lambda is a serverless offering, and DynamoDB table is a database service. So with this, they have a monitoring setup that is very disaster tolerant, we can say. So summaries, we discussed the AWS monitoring and just saw a simple hands-on lab about how to create a dashboard and what are the metrics we can configure accordingly. And also we saw different types of service like X-Ray, Event Bridge, AWS Logs, CloudWatch. In the next session, we'll be seeing the high availability and scaling systems in AWS, or like what all type of scaling and availability features it has. So yeah, hope this was a productive session and see you in the next session. Bye everyone.